Okay, the next we're going to look at is argument and principal argument. So we start with the first definition. Argument. The argument of a complex number z, written as argument of z, is the angle measured in radians, okay, that z makes with the positive real x-axis, okay, when z is interpreted as a directed line segment from the origin. I'm going to explain that. Now the argument is not unique. That's one thing you should notice here. It's not doesn't have a unique answer. It can give us different answers. Okay, because if the argument is theta, then argument can also be theta plus 2 pi n. 2 pi n there is talking about, remember trigonometry happens in cycles. Okay, so in cycles of 2 pi n. Okay. So that means whatever I get for 30 degrees is the same thing I will get for 30 plus 2 pi n, 30 plus 2 pi n. If n is 1, n can be 1 plus 0 plus or minus 1 plus or minus 2. If n is 1, for example, now you're going to get 30 plus 2 pi. Remember, pi in degree is 180, so that's 360. So 360 plus 30 will give us 390. Okay, so you can check with your calculator to see that sine 30 will give me the same thing as sine 390. In the same way, cos 30 will give me the same thing as cos 390. That means the same thing. Tan 30 will give me the same thing as tan 390, and so on and so forth. So there's no particular unique solution. Okay. So that is it for argument of z, written as, if you notice, is a small letter ARG-Z. And I'm going to be showing us really, if you notice, it also says that is the angle z makes with the positive real. This is the positive real x-axis. So the angle from here, depending on where you're going to, it will determine that. I'm going to be showing us that in a jiffy. Okay, so here, for a non-zero complex number z, the value ARGZ that lies in the range, okay, minus pi less than 0 less than pi, that means between minus 180 degrees and 180 degrees, is called the principal argument. And this one is unique, okay, because there will only be one value that is between minus 180 degrees and 180 degrees. Don't forget that. So that means the principal argument is a subset of the argument, okay? So everything in the argument, principal argument is in the argument, but the argument is more like the superset of the principal argument. How do you know argument? It must be between minus 180 degrees and 180 degrees. Remember, the argument that we saw before with the principal argument, the argument has unlimited values. You can see that the values theta plus 2 pi n, where n can be 0 plus or minus 1 plus or minus 2. That means you have so many values that can represent for argument. But for the principal argument now, it has to be values that are between minus pi to pi. I'm going to be showing us that. Okay, so we have 4 questions here, and we want to find, the question here is to find the argument and the principal argument. So we want to use these questions to differentiate between argument and principal argument. Okay, now look at the first one. Your A is 2 plus 2i. A is equal to 2 plus 2i. Okay, now my argument, like we know, is supposed to be tan inverse of y over x. Okay, now what is tan inverse of y over x? In this case now, it means tan inverse of 2 over 2, which is tan inverse of 1. And tan inverse of 1 is what? 45 degrees. And don't forget that 45 degrees. Okay, let's leave that for now. Now, this is it about argument. 45 degrees lies in the first quadrant. Remember, this divides into 4 quadrants. This is 0, this is 90, this is 180, okay? And this is 270. Then coming here now is 360, okay? So 45 degrees is here in the first quadrant. That means between 0 and 90 degrees. So from here to here is 45 degrees. So that is our our argument. So our argument is 45 degrees. I can say ARGZ, Z is 45 degrees. Now, amazingly, ARGZ also, the principal argument is also 45 degrees. Why? Because that 45 degrees is actually less than 180. Remember, that value is less than 180 and greater than 180. Okay, so the good thing about argument is that it can be positive or negative. I can read it either clockwise or anti-clockwise. I'm talking about principal argument. I can count principal argument either clockwise or anti-clockwise. Okay, and I'm going to show you that with many of these examples. So now, but this is not the answer to the question. The reason being that I want to come here again. Remember, we just got our argument to be 1. But if you notice what we have here, your x-axis, your x is, remember, if you are writing it as x plus iy, okay, your x is 2, is positive, and your y is negative. So where is positive y, negative x? This is positive y, and this is negative x. You can see that? So it means that this particular diagram is this way. Okay? Did you get it?